for your bathroom?
Oh yeah, this should be.
Right. With these.
Okay. Now you can open a project which will work with Control O. And then you just select the folder that's been created. Which is like you go up because it's in not in cursor tutor but one. That's going down. Up is the other way. Like go up in the file directory.
Oh,
Towards the root there. That's the word I was looking for. Source. Yeah, that one.
Yes.
Yes. Basically always, actually. Also, if you hit the control backtick, it will toggle this thing. You don't need the terminal open all the time.
Control.
Backtick, top left.
And I find the problem.
This lets you add dependencies. The reason you want to use a tool like Rye for dependencies is that by default, if you just use Python's built-in thing pip, it will install the dependencies globally, which sounds nice until you have conflicting versions from like two projects, which will happen pretty quickly, and then it becomes hell. This part is like easily more annoying and confusing than actually figuring out how the language works. And so don't do that shit. Just do it the right way. That's the kind of thing where you should go on the side of doing it the right way and not the easy way. Okay. Now, a very handy thing this allows for is an evaluation environment where if you type the comment character and then a double %sign, see it gives you cells. There's a bunch of shortcuts, but the most useful one is Shift Enter, which will essentially run the current block. A block is here up until the next one or the end of the file, whichever comes first. Which will appear to do basically nothing. Yeah, sure. Because you've only defined the function but not called it, it's just going to run. So there's no syntax errors in it, but it doesn't really tell you anything. Now call the function.
The function being hello?
Yeah. Yeah, just like that.
What is this doing?
It's taking its sweet time is what it's doing. The kernel means an instance of the Python interpreter that is running in the background. There can be multiple instances separate of each other.
Does the word kernel mean in general? It's a phrase I hear a lot, especially in context.
Sort of like how the word function, procedure, algorithm, process all mean kind of the same thing. Kernel is also like this, just something that's supposed to be core to some system. The kernel of an operating system does things like file and memory management, or it does the actual act of that, but things are built on top of it to abstract over it.
By the way, do you find this kind of keyboard more ergonomic?
Yeah, the thumb cluster especially. For me, it's not so much about hand pain. I think my hands are fine. That said, I've had a lot of friends who were very grateful I recommended this to them. Because some people do have a thing for hand pain and it can end your career. And it's better to just like pay $300 to not do that.
Well, if I ever start feeling hand pain, I'll consider making a switch. Sort of the mindset that something takes more than 10 seconds, it's probably just on an infinite loop.
Yeah, probably. In which case.
What's Jupiter?
Jupiter or Jupiter is basically this notebook environment. Like it used to be called IPython, but now it's been generalized. It's not just Python anymore. Okay, it looks something like this.
Oh yeah, I feel like I'd read about this in the context of an article comparing Stephen Wolfram's one man runs it all approach to Mathematica versus.
I think I've read the same article as you somehow.
It was years ago, but that's the one time I've seen this phrase. Jupiter.
Wolfram's, if not intended, then perceived contempt for everyone who isn't himself has held him back a great deal in software and otherwise.
And math.
Focusing on software though, a language that's not open source doesn't tend to get good libraries unless someone's willing to pay a lot of money and hire a lot of people.
So has Jupiter's library completely subsumed of the Wolfram version?
People still use Mathematica. Mathematica has some nice features that are hard to get otherwise, but the problem is that like 90% of it kind of sucks. and it doesn't get dramatically better, whereas Jupyter does. Not everything that's open source is automatically better, but for big projects, it usually is. And in this case, it is by a lot. What the hell's up with this? Okay, that's not normal at all. When in doubt, reopen it.
Alright, let's see if I can remember how I got that far.
That's cursed. Cursor.
Yeah, I remember that was the first. Okay, I was like cursor, then control back tilde.
That just open the terminal. No, you just want to open the. Actually, luckily for you, it remembers the context. So actually, all you can do is just hit Shift Enter. You don't even have to do that again. ls is another common command. ls means list, and it will list out what's in the current directory. So you can drill deeper into it.
We gotta go deeper.
And Control B will toggle the sidebar. Although not when you're in the terminal, apparently. Okay. Control. I'm running this command select interpreter to pick the specific Python version to use. When file or folder names start with a dot, that usually indicates they're supposed to be hidden in some way.
I feel like I've unconsciously noticed that, but that makes sense.
Right. The search is fuzzy, so you don't actually have to type every letter. And thank God for that too.
What is pip?
Python package manager. All right. All this is pairs. Open up the command prompt or just the Windows subsystem. Actually, open the WSL.
Wait, what?
What's it called?
Oh, this is interesting.
What?
I'm typing in letters.
Oh.
I think it's showing up in the search bar.
Go to Task Manager.
Yeah, I think my computer's just having a moment.
94, 88% memory utilization.
Yeah.
That's high. Well, for lack of a better idea, try restarting it.
My whole computer?
Yeah. I once imagined that by knowing from
It's like,
first
why is
principles-
Chrome using about 600 megabytes of data when there's like barely anything interesting going on in the tabs?
The people want to know.
Yeah, even my control tabs are my computer is just fucked right now. Cool. All right, let's restart. So I'm still not used to.
Does it let you just force shut it down by just holding power?
Probably. It's not used to Windows 11.
Okay. Well, anyway.
Anyway,
Here are two values in the meanwhile.
I love those two.
Yeah.
They are the -1 sets.
There's false true. Of course, there's integers. You can add underscores in between them. The underscores are purely just for grouping. They don't have any semantic meaning. Not every language
Okay, yeah.
has that.
Because you don't want to use commas for obvious reasons.
Yeah. Then scientific notation is supported, though you must put the leading something.
Sure.
To do exponentiation, you don't use that caret. Not in Python. You use a double star.
Right, that makes sense.
The caret is reserved for some of the bitwise operations, which we're not going to get into. Those are usually lower level than are your concern, at least for now. Strings. Double and single quotes are equivalent. If you want a string to stretch across multiple lines, you can use triple quotes. It's also double or single.
Wait, what do you mean?
Look at this. If I do there, parse error, because it will say the string is not terminated. Because if you do just the one string, this is a simple line literal. Yeah. And all these are called literals because they represent the literal value rather than being a variable for it. Like if I said x equals false, well, x is then false, but it's not a literal, it's a variable. Which is also why it's highlighted in blue.
When you say highlighted in blue, like, so like, again, what editor you're using?
VS Code cursor. That one, like saying that's why is getting the direction of causality kind of backwards, but whatever. Booleans, ints, floating point. There's no complex numbers. I is so commonly used for a loop variable for I and something because it's supposed to stand for index that it's J.
Right, I've heard about engineers use this a lot.
Yeah. Just J by itself doesn't do anything. J by itself is a super common index as well next to I.
Okay, so wait, I know there are like floats and doubles for reals. Is there like complexified versions of like every real type?
No. Just floats.
Okay.
Other languages, you can do this. Lean, you can really easily do this. Actually, Lean, you can define it as like taking a tensor product with complex numbers for an actual complexification. But here, you're just gonna have to deal with that. Oh, there are in complex ints, so the Gaussian integers are represented technically. Although I think people rarely call them that or even know.
It's like, what's actually the official name of the complex float type?
Just complex.
Okay.
There's no term for, I think, complex int. In fact, wait. I'm wondering if, like,
My computer just opened and closed some window 5 times in a row.
okay.
I've never seen that before.
All right. All right. In Python, integers are actually arbitrary precision.
What is this?
I have no idea, dude. I think it's just inviting you to make a new one. Okay, integers are arbitrary precision, which is not necessarily true in every programming language.
Arbitrary precision. How does that work?
Under the hood, it uses a C library called GNU Multi-Precision, GMP. But it uses a library that will, instead of representing it as like some fixed bit, will like a list of numbers that are.
So if I keep adding digits, it will just like be able to expand in real time how much memory is taken up.
Yeah. Using the smaller numbers, I mean, if a number's small enough, it will be represented with a more efficient native built-in data type because that's faster, because the CPU has special hardware support for it. It'll be like, it can be easily like hundreds of times faster.
Tell me about it.
Yeah, but like having to think about
ran like a string multiplication algorithm before, like an integer multiplication algorithm, and it goes so slow after even like 100 digits. Because that's to do like the actual manipulation of string for loops. It's hilarious.
Oh god.
Oh yeah.
Floating points are not arbitrary precision. I forget how many. I think it's 64 bits.
Yeah, and I also know
Lots of
that
variants.
and like the way it works is kind of complicated because it's like the more it because that's like think like all right, how many bits are before decimal point, how many are after?
Actually, this is a project by a guy who, by himself, this project is actually technically correct, but this guy is like such an unlikable crank. This is basically implementing like the Levi-Civita field. It posits a number called a Grossone.
Who's this guy?
Some random fucking guy.
Yeah, I think I have seen this thread before.
So wait, is floating point called floating point because of the fact that the
The
decimal
dot
point.
floats, yeah.
What?
You can move around. It's just as simple as that.
Why is this preferred over, say, having a fixed number of bits for both sides of it? And just
Because it's more important to be able to represent certain parts of the numerical range. The unit interval has a lot more numbers that are mapped into it than the higher numbers. The higher numbers have inherently lower precision, and
because practically, if your number is above 1,000,000, you probably don't care that much what's after the decimal point.
that or it's like the computation that produced it inherently has less precision anyway. Plus, just on like a realistic level, when it comes to continuous quantities, at massive scales, like small errors, especially if it's multiplicative, have like wild swings.
That makes sense.
This just he basically just introduces a symbol, which is like basically a hyperfinite number, and then constructs power series out of it, like 1 plus h squared or whatever. Because h itself is just a symbol that can be given a decent semantics, this works fine on a computer, and you can practically compute with some infinities. Not like everything. Division in this might not always work out. Problem, his thing works. Problem is he's a huge crank who insists that it's like not math or it's not non-standard analysis or that it's more powerful. It's just a guy taking like a perfectly good invention and just ruining it.
Many such cases.
Many such cases.
Alright, so should we try this again from the top?
Yeah.
Cursor. Not this is optimal, but like are there like so many shortcuts that like people like really get into it will just like never use their mouse and can just like keyboard their way around anything.
How much have you noticed me using the mouse?
Doesn't look like you do a lot.
Yeah. Yeah, it works like that. Some things are better done with a mouse, especially if you have to manipulate a compact region that is otherwise unstructured. But anytime something's can be algebraicized, you can put it into a menu and then keyboard shortcuts work well. Like until we get like a brain-computer interface, a keyboard with a trained operator is quite hard to beat because you can do almost like 100 actions within one movement. This guy has good notation though. For his, instead of H, he writes this one and then puts a circle. That's why it's called a grossone, a big one, a gross one. Which I actually like. I think it's good notation. If it didn't associate with this crank so much, I would use it more. Plus, see, it is the unit infinite number.
The infinite number.
Actually, more useful than picking the regular unit is picking the non-standard unit, because by division you can get regular 1. But with only standard numbers, you can't get a non-standard number. It's like picking like which epsilon.
Sure. But only the real numbers are the only complete number field. You can throw more stuff in there, but it'll never be complete again.
I'm fine with internally complete, so that's okay. I actually find it quite satisfying somehow that the hyperreals are totally disconnected. Because the shirt isn't obvious, because they sure look connected.
Again, it feels like you're making something complete-er and connected-er than the real line, but
no.
no.
It's still fascinating though that connectedness was even more complicated than I thought.
By the way, do you know the explicit construction of a hyperreal field? The one that doesn't require any arbitrary choices?
The one that, what's his name? Kanave and
Shala.
No, I just saw their paper. Like everyone assumed that there isn't one, and they said still there is one.
And I can tell you in like 2 sentences what the trick is.
Which is
Okay, instead of picking an ultra filter, so a well ordering of the real line can be encoded as a set of ordinals,
yeah.
which are lexicographically linearly ordered.
Okay.
So just take an ordered ultra product among all possibilities, and that's it.
Okay.
So it requires choice because without choice there might not be any ordering of R.
Yeah, that's the thing.
But if
Let
there
me
is
just
one,
let me just well order the reels and just pick out of it, like I'm picking out a fucking handbasket.
yeah.
That doesn't feel that satisfying to me.
So just take all the well orderings of R.
Be right back. I'm gonna have to get a bigger basket to fit them in. This is why I tend to just work with the more axiomatic theories of it, because I'm like fine with not trying to break open the black box of the number and just letting it be.
Let it be.
Plus, like from some of the stuff you have been saying, really hammering that you can have collections which are like impossible to find elements for.
Yeah.
This is indicating me yet more evidence to just take it, the number as the primitive object and just like deal. So far, this has worked out pretty well throughout my life, where I've not felt like that much need to ontologically question like 4. That said, I've definitely questioned 4 a lot more than like almost anyone else. But there are levels. Blah, blah, blah.
Well, I just think directly in terms of the universal sets of V, so these things do matter to me.
How do you feel?
I mean, it does bother me when people say the hyperreal numbers and they aren't actually talking about any unique hyperreal field.
Hyperreal field. Does that make you feel better? What if you extend them with what's his name? Philip Ehrlich has some paper.
He's the surreals guy.
Yeah, he has one where I think under NBG, if you take the maximal hyperreal field that's not set sized anymore, it's isomorphic to the surreals. called absolute arithmetic continuum and the unification of numbers great and small.
I can believe that. That sounds like it should be true.
Yeah, and then I think is
Though, of course, it requires you to ignore all the interesting structure on both hyperreal and surreals, because they both are a lot more than their field data.
I mean, for the surreals, there's the whole tree ordering and the treeness of it.
So that's the special thing about the surreals, and the special thing about the hyperreals is their saturation properties.
Do the surreals not have saturation?
Are the surreals technically a hyperreal field? Well, I guess under that framework that Philip did, they are. It's not really how you're supposed to think of them, but I guess, yeah, you could.
Yeah, and then I think if you take like, was it maximal set sized sub fields, you get just like more familiar hyperreal ones. As just like a working man, a mere commoner, I just use them, man. So I do like the surreals though, just for their great elegance.
Yeah.
That's having manipulated a lot of tree-shaped data structures. Conceptually elegant. Lots of stuff does not naturally fit into a tree framework. Graphs are the biggest one, and graphs, unfortunately, are a more and more important data type. It's still not. What the fuck, man? Could this be like some firewall thing?
Is this the point where you're just gonna say, Elliot, just fucking get a MacBook already?
No, I did think it, but I thought it like at the beginning and not now.
Of course.
Although since you had mentioned, I'm just gonna show the one.
Oh, yeah. Into my notes.
What did you say was your budget again? Like 1,500?
1,500 will be fine, yeah. Oh, yeah, yeah, sure, I'll buy your old iPad, why not?
If you can shell out slightly more, this is the one I recommend. This is a very good configuration. It has like an adequate amount of memory. And a terabyte of storage is fine. CPU is good enough.
No, just send me that.
Okay. Oh, for the new iPad, I got an engraving on it based on the words from the Fields medal.
Ooh.
They come from, I don't know if you've ever seen the words.
No, what are...
They come from Marcus Menelaus's Astronomica, which is the first known book on astrology.
On astrology.
Yes, on astrology. Back then, they were much more closely related, of course.
Sure.
The
Who was the one who like famously like just declared without evidence that the structure of the solar system was based on the platonic solids? Like the otherwise respectable famous scientist who had this belief.
very possibly Aristotle. I had a whole argument at Vibe Camp with a philosopher who amazingly had heard of Villaver's writing about Hegel, but was convinced that attempts to formalize it or
Kepler. Yeah, it's
Oh.
Kepler. This is the thing I was thinking of.
That's especially funny given Kepler's work to, if anything, dispel this idea.
I mean, yeah, this is often brought up, and like him and Newton's beliefs are often brought up as, yeah, at that point, very good, reasonable mathematicians and scientists also had these crazy beliefs.
The Platonic solids to me is just crazy for a much simpler reason that they just have corners. And when in nature has anyone seen something like a large object moving reasonably quickly in like right angles? Like intuitively you can see the heavier an object is and you try to deflect it, that its deflection will get less and less as the mass increases. And if it had infinite mass, that it should be an unstoppable force and shouldn't be deflectible at all.
By the way, do you know how to prove there's exactly 5 platonic solids?
At one point I had guessed from some group theory, but I don't know. How do you prove it?
Like the one that like, everyone has seen the argument that there's a most 5 due to you can't have 6 triangles at a point and blah blah blah. But the actual constructive thing, not many people have actually gone through that labor of verifying they exist. It's an exercise in Archin's algebra group theory book, and he says, exercise, prove that they exist. Hint, literally do the real coordinates.
As in just like draw one and
Like the dodecahedron has 20 corners, that's 60 real coordinates. Compute them.
okay, so proof by like write them down.
There is a right way to do it, but it does require some like really clever group theory.
Here it is. The book starts by reminding the disciple we're subject to fate, which are encoded in the stars. And mathematicians have definitely gotten used to
What's
working
this
with
book called?
coding.
Astronomic.
Astronomica. And then
It feels so astronomical. No.
Marcus, yeah, that one. Until the disciple complains things are becoming too hard and excessively obscure. That part as a mathematician is definitely relatable. And then this is the section that ends up in the Fields medal. Well, a snippet of it ends up in the Fields medal, where the master says, the object of your quest is God. You're seeking to scale the skies, and though born beneath the rule of fate, to understand fate's law. You're seeking to transcend conditioning and make yourself master of the universe. The toil involved matches the prize to be won, nor are such high attainments achieved without high prices. Which is pretty base.
That is based.
And so on my pencil, I put the word scale the skies, and then the object of your quest is God. It doesn't let you put the whole thing. I like the phrase scale the skies, especially. And, well, master of the universe, that's the spirit of math I'm in. I am convinced that even pure math can be a tool to gain power, as surprising as this opinion seems to many.
Here's a fun exercise. Come up with a mathematical structure with a unique, undefinable element.
I don't even know how to begin to do that one, actually.
It is brutally hard. Harvey Friedman famously used this as like an analogy for God.
But it is possible.
It is possible. Because in first order logic, you can't just have the infinite disjunction of it's not this, it's not this, it's not this.
Huh.
So the structure would have to be countably infinite, and there are such examples.
Okay. Oh, this was yet more type stuff. Abstract type. Inference. I don't even know what manifest typing is. Well, you can open the terminal directly.
I think this is just not gonna happen.
Fine, then open command prompt or command exe or whatever it's called. And then just type Python 3 and hit enter.
The space?
No, one word. Also, your thing of like clearing your fingers as if they're gonna be cut off for typing something wrong is kind of funny. Okay, well, type some expression.
Hello is not defined. Did you mean help? Help. Help.
Wait, type help with help. I've done that once.
Help. Like this?
Yeah.
There's no documentation for it. No meta documentation on helping. Help me with strings. Help?
Why is it not found? Is this not have documentation bundled with it or something? Try help event. Wow. Dude, even the help is 10 numbers. Okay, well, here, try like false equals true, which you no doubt know what the result is going to be, but you have to capitalize it. It's case sensitive.
Oh, really?
The whole language. Languages in general are case sensitive, and the ones that are not are a mistake. It leads to so many problems because.
Okay, well, I am inside help still.
Oh, hit. You can either type exit or I prefer hit Control D. Control D will type the end of file character, which in this case did nothing. Okay, try exit then.
Literally type exit?
Yeah, just like. Oh. Well, okay, there. Now I typed it for string and it actually did something.
Oh, because I was already inside help.
Okay, well, that's good. Finding stupid bullshit like this is a. Okay. The Control C is like the default cancel button for most programming stuff. Like you run something in the terminal and just like you realize that you fucked up, just mash Control C and it will probably work. Technically, the program can completely ignore it, but because things aren't written by total psychopaths, it should work. Thank God, too.
Conventions are nice.
Yeah. Well, of course, there's 1+1. More interesting programs. Oh, this is worth noticing. None. This will come up a lot.
False equals true. False. Yay.
An object frequently used to represent something. This is like a shittier form of the option type from Lean and otherwise. Okay, that's one way of putting it.
I love that phrase. Annihilation law.
Yeah, there's introduction and elimination rules. There. In Haskell, the none would be, well, nothing, and the just, except in Python and most languages with none, they conflate these where here you have this disjoint union, but in Python that union is not disjoint. So it's more like A with none as a possible value that can be inhabit every type. And so you typically have to check for it specifically, which is aggravating.
Yep.
Get used to seeing that value, because when some computation goes wrong, you're going to see it, and it's going to say something like, something wasn't supposed to be none, but it is. And then you have to find it. Oopsies, yada. Not important. Built-in types. Okay, this is more important. Types are pretty important. The built-in types are numeric, sequences, mapping, classes, instances, exceptions. Okay, well, numerics we went over already. Numbers. Real, complex, integer. Actually, I should say them right here. There are three types, int, float, and complex. Booleans are subtype of integers identified as a field of two elements. Double means 64 precision. That's a historical thing.
All right, float is 32, double is 64.
Yeah.
You can even have quads, right? If you really want it.
You can go up in ML, it's not up but down in precision, where in ML 16 bits, a fourth of that precision is pretty common. Because it turns out the extra bits are just like fuzz anyway, and less stuff.
I mean, are we actually though, like, why in modern computers do we need to be penny pinchers about bits?
Because when you're using, in this case, it's actually vital. Because the use case in ML is not the same. You don't need to be a penny pincher when you're just like typing stuff because you've got stuff to spare. But the whole point in ML is to use the entire computer as much as possible, and you can always do that better with. And so that one, there's always this pressure. And because of the thing I told you last time, where memory is 100,000 times slower to access, or a lot slower, cutting the memory usage and movement lets you pack more data, which can improve the speed of a program in a nonlinear way by a lot.
So you said that there's there's ways to run int so that it's like not that it always uses as many bits as it needs. Is there a similar thing for floats, like a dynamic float that uses precisely as much data as it needs to describe as trying to describe?
Usually not. For ints, the arbitrary precision is just because ints are discrete, you can have like a meaningful right and wrong answer for arithmetic expressions, whereas for floats, that's not really the case. Like asking if two floats are equal is just fundamentally
The wrong question. Right, and I was told that like you should always say that no, don't ever ask if floats are equal, ask if they are less than 10 to the negative 12 or whatever.
Yeah, I think you can, as someone with some experience of continua, I think you can see why. That said, languages that don't let you write equals equals for floats are very annoying. But this one.
Fun fact, and one of my discoveries in that gaming engine I showed you was that if you walk up to x equals 0, to like the absolute left side of the screen, stand there for 28 seconds, you then die.
Why?
So if you walk past 0, there's an instant death order. That's intentional. And like in Game Maker Studio has like an inherent fuzz factor of 10 to the negative 13. So you technically die when your position hits x equals negative 10 to the negative 13. Okay, well here's the actually funny part. The dumbass who programmed this engine, instead of having a simple 90-degree downwards gravity, had it basically be essentially pi 3/4 radians. Which by float point arithmetic ends up being not perfect. So eventually, after 28 seconds, you get enough decay for you to die.
Actually, this is a good point to bring up since you had mentioned it. All the things that in math that depend on transcendental numbers like pi, e2 for that matter, translating them into algorithms is not always trivial, as illustrated here.
Yeah.
Usually, if you care about accuracy, it's typically better with transcendental numbers because they are transcendental to abuse that fact and treat them as constants or as a symbol until the end. And then only at the end if some sort of numerical simplification is required to do it, but do it in terms of pi otherwise. And thankfully, no possible algebraic equation you could write could ever use it. Real convenient that.
Yeah.
Okay, here's the basic set of operations, most of which you're already familiar with. This is floor division. This will just round. So like 5 floor divided by 2 will just be like 2 instead of 2.5. Usually you'll use this one. This is only if something needs to be like an actual integer and not just a float.
Floor portion.
Yeah.
Got it.
There's remainder. There's to get the div. There's an operation that will do both of these in one shot called divrem.
X unchanged.
By default, like this is an operator called this is called neg underscore underscore neg underscore underscore because that's called pause for positive, which by default won't do anything because it's like multiplying by positive 1, but you can overload it to do whatever you want. Some people for their classes will overload it for something more interesting. Typically, it's just ignored.
And are these like again like will work for? Is this specifically integer arithmetic? Is there like or is this
Any class can have these overwritten,
Mm-hmm.
and you can define different combinations of what it should do. So like an class A plus another class A plus some class B.
Like if it's an integer plus a float, it won't cause
Yeah.
any problems.
Yeah. The way that this tends to be coded in Python is rather ugly, in that essentially we'll check the types of arguments and we'll dispatch on them, which is these kinds of if statements are rather slow. In general, anything that has lots of conditionals that are chained together, well, I mean, since an if statement is creating a binary tree of possible program flows, depending on which branch is taken, because exactly one branch is taken because of how an if statement works. And then if you nest your ifs, you'll end up with a binary tree. And if a tree is deep, this will slow down performance. Computers and CPUs actually have a thing called branch prediction, but they'll essentially try all the branches at once, and then when it's resolved which one is the right one, just instantly return it. It's called speculative execution as well, and this has led to, well, people abusing it to do hacking. Abusing how computer optimizes expressions is a very common source of security vulnerabilities, as you've noticed with the floats, because that is a security vulnerability just that no one would care because it's a video game, but you'd care if it's your bank account.
Yeah.
These will cast them to what they sound like. You get div mod. Oh, not div rem, div mod. The reason you do this instead of that is I think this has a specialized implementation that will do it more efficiently.
That makes sense. They're basically the same algorithm up to the last step, so.
One that has not been implemented by Wish was min-max, because min and max, of course, are very easy to write. Actually, here, this will be your first assignment. Implement the min function.
Okay. In here, I'm just
Yeah, right in there. And don't worry about the syntax being exactly correct. In fact, before you even do that, just like write it down on here.
Sure, pseudo-code it first, then worry about syntax.
Yeah. And then as your computer unfucks itself, you can use its full power later. Something to look forward to.
And should I be imagining them as being floats and whatever?
Well, we'll see. Start by just defining a signature, like literally write def min and then min of what, and what should it return?
Capital def. Whatever. Def.
Just do lowercase for the sake of.
Yeah, not right about two next. So def min, and next up I put in what the inputs are supposed to be.
Yeah, 0 to infinity of them.
So do I write like two because it's a two input function?
No.
Oh, you
like literally like Python. Like you're just writing it as if it was computer code, just on paper.
Okay, again, I've not remotely internalized the syntax yet.
Yeah, this is how you're internalizing it, by struggling through it.
Okay, but I'm not going to be able to magically deduce in my head what the right answer is. So.
Well, that's why I'm here. The first thing is def is, besides not being capitalized, is just its own word, and it starts the declaration of a function block, and then with a space is the name of the function being declared, which is just min. And then you put a parentheses, not like here, you put paren. And then within that binder block goes the names of the arguments. Optionally, they're types as well. Don't worry too much about the types.
And
okay. That is the next thing is that these are names, and if you don't care what the names are, call them like A and B or something. You're just giving a type. And one that will locally, say you wanted to actually use the int function or the name of the int type within the function, which you don't, but if you did, this would actually shadow it, and within the scope of this function, basically everything indented more than it, int would refer to this int and not to the built-in one. Like if I do this. Int here is just the number 2. So these two ints, despite having the same name, mean totally different things. Because you can just rebind names.
Okay, so wait, what was I supposed to do here then?
Just call it like A and B. It'd be like def, min, A is an int.
Oh, A:\int, B:\int.
Yeah, for type signature. Usually it would be like a name, which is like, or actually the technical term for a name in programming is called an identifier. Anything that can be used as a legal name, which is basically a sequences of like letters, numbers, and underscores. And then a follow-up colon that you wrote, and then an actual implementation.
Okay. So let's see here. I mean, I want to say something like, if A less than or equal to B, spit out A, else B.
Yeah, that's correct.
Okay,
Literally just that will work.
I'll try it.
Yeah, like don't worry about like how the less than we implemented. Just take it as a primitive.
Okay, if
Yeah, if A is less than B, then return A, else B.
if I type out return.
Yeah, like here, I'll just show you. This is the more full syntax. If A is less than B, there's thanks. Python is unfortunately not an expression-oriented language. It's more about statements. Where this return will like break out of the entire function and return, well, whatever it says it's returning. Like another way, there are many ways to write this function. Like another one can return. This is doing the same thing, but in a one-liner and is an expression, so you can actually assign it to stuff. Like you could say that out equals the result of that and then return that. Whereas here, the equivalent would be like out equals A, equals B. Also equivalent, but kind of ugly. Matter of taste. It's possible to make this one like too ugly as well by just like nesting too many things or trying to put the whole if-else tree in it.
Also, I resisting the urge to be a smart-ass mathematician and just reduce it to plus and absolute value.
For which? Oh, for the min.
Yeah, you could also say it's the average of the two minus the absolute value.
Okay, there. This is a good thing though.
Like, I know that's not the right way to do it.
But it could be. This is actually getting into an important issue, which is like the min of what? In the case of integers or something that basically supports like ordered field operators.
That's right. The
something
definition
like
is this one is purely order-based without any group structure.
Yeah. Okay, now say if I wanted to take the min of a whole sequence. Sure.
I mean, I would just recursively do min of the first two, then min of that.
It's essentially doing that anyway. But this one is actually calling the two argument min function.
I'll actually try to understand the syntax precisely. All right, so define min. So here you want it to be an arbitrary list. So it's technically one input, but then one input is a list. Am I reading that right?
Comparable. Is that not the name of the type? Okay, this is slightly more generic syntax. This is actually only in the newest version of Python, but should be relatively readable. It's saying that in this block, this is binding the name t to some type that's arbitrary, and all you know.
Computer makes so much noise. What is it doing?
No idea.
Oh, my task manager. What the fuck is up my computer right now? 83% of memory is being used on bullshit. What the fuck?
Okay. Comparable means anything that supports like less than or greater than, essentially orderable or totally ordered.
Okay, that
Being
makes sense.
totally ordered was like too much for the masses. They use words like comparable or ordered or something.
Okay, so the point, so then T's represents types, like you're saying this is a multi-typed
This is
function.
that in the context of this function, T is abstract but fixed within this context. This is called a generic because now this implementation, well, will apply to anything that satisfies like total ordering, which is a lot of stuff.
Yeah.
Whereas if you wanted a more specialized one, then maybe you would do like def, min. Also, the name T is just conventional for type, but it's just an identifier. It can be anything. And then you would instead use, say, the more efficient implementation, assuming it is more efficient. Oh yeah, another issue that comes up here that's worth noting, edge cases. If the list is empty, what's its min?
Mathematically, the answer is infinity.
Yeah, and the
Okay, but how does this actually work? Is that actually what you're supposed to get out of min empty?
unfortunately in some languages it will give you infinity. In this case, it'll quit.
What is infinity? What is infinity in terms of programming? Is that like like NaN?
No, there's literally a floating point value called inf. To construct it, you have to write something like this, or like float.inf, and it will, I guess float.inf won't work. It'll refer to some underlying thing. Basically, it's like a symbol that's given. Actually, I forget. Floating point, I think, might have inf built in. Nans essentially correspond to all the indeterminate cases. Part of my interest in non-standard analysis was using it to resolve some of those previously indeterminate cases. Because very often in programming, unlike in math, you don't just have like two arbitrary, potentially infinite quantities minus each other, and then you have no idea what they could be. You will have infinite quantities, but often they'll be produced as like the end result of some computation, and very often are linked together in some way. Say, like one of them is twice as much as the other or something. Well, then there's no problem. It's just like negative infinity.
So is negative infinity a separate floating point value?
Yeah.
So it's just okay.
You can do it like that. You can also do it like that. But also notice that for types, well, like for integers and like numeric types, infinity and negative infinity are fine. But not everything, like say a string or whatever, doesn't have a good notion of infinity or negative infinity necessarily.
Or complex types, obviously.
Yeah. Oh yeah, where they have a whole circle of infinities and which one?
Yeah, usually in complex analysis, that is all called of one singular infinity. The one-point compactification of the
Oh yeah,
complex
the Riemann sphere one.
as opposed to the two-point compactification of the real line.
I had a very satisfying non-standard proof that the space of n's in higher than a 1D has one component for R at least, which was literally to just do it the obvious way of just take a bivector as a rotor that just and consider some unlimited length ray and just rotate it and notice that it stays in the infinite segment always. So literally just do like the obvious thing of like draw a square, draw like a little circle that's supposed to represent the finite bit and everything else is out at infinity, and just notice, hey, I can spin it around at infinity and it'll stay in infinity and therefore it's connected. Which is pretty satisfying proof. And the reason it doesn't work in one is, well, like spin to where you only have one dimension.
Yeah.
And these kinds of like little concerns with generics, like even there where like subtleties start to creep in, and often it's easier to just write a concrete implementation for the few most important cases and then make it generic. A very common failure mode, especially for mathematicians, is to try and do it like from like the music of the spheres top down, where you're trying to figure out like the ideal generic chain and layer them starting with the highest abstractions. Don't do that. It's not a good idea. It's just like with math. Like all these abstractions were discovered after people had to grind through the concrete shit.
Oh yeah,
And got sick of it. Okay, well, remind yourself vigorously. vigilance.
Mm-hmm.
You're damn right you should define it to be that.
I mean, I've definitely also had plenty of experience in reverse mathematics of like very choppy ways of doing things due to like the constraints of my environment.
This will be interesting then. These are bitwise ops, whatever. Don't care. Oh, hashing. Hashing is a very important concept in programming. It's like almost magic, honestly. You will have to look up hash tables and how they work and even write a basic implementation of one that uses a vector with dynamic resizing. That's a homework assignment. This is well within your grasp. What hashing is, though, is a function that essentially takes something and maps it to what's supposed to basically be a random memory address, essentially a random integer. And the key is that they should be random so that two objects that are different would have almost certainly have different hashes. This is not actually possible because, like, say you're hashing into a 64-bit integer, then you can only have 2 to the 64 possibly unique things by injectivity.
But in practice, you should never find collisions.
Yeah, so it's fine.
So I'm
This
assuming
is
this is
like
related to the hash functions of cryptography.
yes. The hash function of cryptography are a special case of this. Hashing is like I'm really struggling to overstate how important it is.
It's like, what's the kind of thing that makes it really important?
Because a hash table allows you to create a set or collection and then access its elements or find an element in constant time or asymptotically constant time, which in practice basically is constant. Whereas, like, okay, imagine if I have a list. In fact, not even imagine here, I'm going to have a list. Move this code though, so that it's not polluting my Proto-Indo-European.
This reminds me of the fact that one of my math friends really loves about this. I don't know
Oh
if
yeah,
it's
this is a good
the inverse
acronym.
I
want so efficient
a
that
constant.
there's like 2 or 3 optimizations that make it faster and faster, and you need all of them to get to the inverse acronym. But even if you give up at like the first one, you already have, I think, like an iterative log, which is insane. And it's just like not necessary in most cases to have every optimization. This data structure is pretty great.
What is this data structure?
It implements an equivalence relation, essentially, a partition, and then it lets you. It gets its efficiency by, for every equivalence class, by tying all the elements to a specific representative. And then by chaining them together, you can very efficiently figure out if something is in the equivalence class.
Huh, makes sense.
And since they can represent classes, well, of course, they represent an equivalence relation generically, or a partition.
Hey, actually have a theorem about finite partition theory.
Which is
that the axiom that says you can assign to every finite that you can choose for each finite set a non-trivial partition on it is equivalent to odd choice.
odd choice?
For any family of finite sets of odd cardinality, you can choose one out of each. Yeah,
Is there an axiom of even choice?
There's binary choice.
What, you can like.
I mean, yeah, you can also have even choice, but yeah, there's binary choice, even choice. These almost never come up. Like I had never even conceived of odd choice prior to me using it for this theorem. Because that's so specific.
Yeah, you and me both. Certainly, I never thought about the axiom of choice and the parity of a number. And yet, here we are.
Here we are. Like I said, it was a surprising theorem.
Okay, look at those. X's. This is from Haskell. It's X's because there's more than one X. One in X's, which is not. The in is yet another thing that can be overridden as like contains. This, the way that it will actually run, because it's a list and is ordered. And this is how you write a list, by the way. You put some square brackets and then like stuff in commas. You can nest lists. In Python, lists can contain like elements of different types, but this is almost always a mistake. And if you're doing that, you fucked up and you should be using a different data structure.
Yeah, I can imagine that would cause a lot of problems.
Yeah. And they can recursively contain each other. So if you want, there's libraries like NumPy for this, but if you want a matrix, this is a 2 by 2. And the way that it finds elements is that it will just look one at a time. It will like def list contains. There. This is the default implementation. It's just check them one at a time.
Cool.
Well, what's its asymptotic efficiency?
Of what?
Like asymptotically, or rather in the worst case, how long will that take to run as a function of the length of the list?
And you're asking if this is the equality list check?
Yeah, not the equality check, the whole algorithm. Assume the equality check is an atomic operation or constant time.
Okay, fine. Out equals for y in excess if y equals
A given element.
I mean, it just sounds like it's linear time, right?
Yeah,
The
it
length
is.
list.
Yeah, exactly. And in general, to analyze the efficiency of something, you can split code up into basic blocks. In this case, the for will be like linear in the respect to the list. And then if you have nested for loops, we'll multiply each one. I mean, it should make sense. And then by combining these, you can figure out a bound for the runtime efficiency of something pretty easily. This is not like the biggest consideration in practice, but for basic understanding, it's pretty important. Okay, but linear time.
I mean, you know, at some point, someone had to like suss out like what are the best ways to do anything, but we know the answers to those questions now, and you don't have to like go by yourself.
Anyway, the linear time. Say if you have a big list that's slow, parallelizable, slow though. Hash table takes it from linear to constant time, essentially independent of the length, which is quite remarkable.
Really?
Yeah. It's not literally constant time because there's usually the way a hash table is implemented is there is nonetheless an array or a list under the hood of some fixed but big enough size that using the hash function on object will give the array index to put the object in, and then by hashing the object it would tell you what the array index is, and then you check that one index, and if it's there then it's there, if it's not, well, it's not there.
That feels too good to be true. What am I missing here?
One is that it's not literally constant time, but it's like
What's
essentially.
the
I mean, you're not missing all too good to be true. Hash tables are really good data structures. They're probably the most important one in all of programming. Even a list is essentially a hash table where the domain of it is a contiguous range of integers and it's ordered. The ordered thing is important. Hash tables by default are not ordered. There are versions that people hack to it, but the default version is never ordered because that wouldn't even be possible in general.
I have to decide what I'm going to do for my self-study in Python. So are we still suggesting that one you gave me before this?
Yeah. Also, the best way to do it is like find something that you just like find enjoyable. Like the thing I did for Proto-Indo-European is like a pretty simple exercise, but because it has its own motivation. Like just like math, programming has many tendrils, and if you pull on one long enough, you'll end up enmeshed with all the others. And then as you hack your way through the jungle, eventually they'll all tie together and make sense.
What is this website? Is this is this an actual university?
This is from Berkeley. It's just like the Berkeley freshman CS class. This guy, when I had said projective geometry and some non-standard analysis, this was the guy that I was thinking of, Michael Strobel, who has his PhD thesis up, which also includes code. He said what it did. So this guy does projective geometry by implementing what's called the Levi-Civita field, which maybe you've heard of, maybe you've not.
I've heard of that name in a very different context. Well, not very different. Their connection. That's like their thing that they're most famous for. Actually, he's most famous for.
He's most famous for the connection, yeah. This is different. Yet another non-Archimedean field. That said, I do consider the axiom of Archimedes to just be false.
Like, what if it falls like in the real world?
Yes, even in the real world. The idea that there's like different levels of scale that might be like fundamentally inaccessible to each other doesn't seem that far-fetched to me. Like the simple one being things like below Planck length or so. Anyway, each member of the formal series of rationally indexed things where epsilon is supposed to represent some infinitesimal.
We're actually kind of just debating that in the Foundation's Discord. Excuse me, the Foundation's channel, the math Discord. You should join. It's fun. I have lots of fun chats there.
I don't even know there was a math Discord. Wait, which math? Like the? Is there an official math Discord?
Not sure official, but it's 200,000 members and it's just called math.
Okay, probably then. Math Discord.
Yeah, that one's for joining. Yes, I hang out on the Foundation's channel. And
26,000 online. I'd like to socialize and share math memes.
Thanks.
Give me a cat channel. I want to type setting in LaTeX. Math people really are cat people, I guess.
Of course we are.
Do you have a cat?
No, I'm a pupper person.
You have a what?
I'm a pupper person.
Hmm. Okay, well, I'm in the math Discord. I wonder if they...
Look at her.
Oh, that's sweet.
She's smiling at you.
Okay. Wow. I have quite a different opinion. All right, actually, this reminded me of something. Because I was thinking that you can approximate some irrational as the ratio of two unlimited integers, or by a hyper-rational. And then I'm thinking, okay, but how would I represent a hyper-irrational? Would it be as the ratio of two hyper integers? sort of like iterating the non-standard construction.
Wait, you're trying to what?
Like I've just got some irrational number I. Well, it'll be infinitely close to some hyper-rational number, to a lot of them actually.
Yes.
And then of the ones it's infinitely close to, its representations should be just two unlimited integers.
Well, it won't be literally hyperintegers.
Why not?
Wait, the array ship two hyperintegers is a hyperrational, right?
Yes, and I'm saying the hyperrationals that in particular are infinitely close to a standard irrational.
Yeah, they are. Yes. Okay, good that much.
But then, so now I get this trick of representing a standard irrational by a non-standard rational.
I agree.
Okay, and then
So, for example, pi can be written in this form.
I just think of taking that decimal place and moving an h off to the right, which is pretty satisfying. But then iterating this trick where I have some non-standard irrational. Well, finding some like star q. Where's that? Something like this. So I keep jumping up in scales. Where that's supposed to be like a double extension. Sort of like how the non-standard numbers are bigger than anything that can be formed from the standard numbers. And then these bigger ones, hyper would be bigger than.
I guess that makes sense. Is we have to be clear about like how clear we are about the relationship with the original real line. So like, let's say I hand you just the surreal field.
Yeah.
I ask you, show me pi. This is impossible.
Okay.
There's not a morphism on the surreals that moves pi by an infinitesimal amount. The only real numbers you can actually suss out are the algebraics.
By moving them an infinitesimal amount.
Like you can define square root of 2. There is a unique number who's greater than 0. There's a unique number which has a square root and which squares to 2. That's the square root of 2.
Yeah.
You can't define pi. You can list out a bunch of rational inequalities, but that will only specify it up to its halo.
Oh, okay, I see.
There is literally no meaningful pi among the surreal field.
At best, like a sort of cloud around it.
Yeah, there's the pi cloud, but no pi point.
Okay, I can live with that since the cloud can be made so fine that it's not that bad.
Yeah. Yeah, but the only way to actually suss out the actual real line is if you also provided the structure of the birthdays.
Okay.
So pi is the only one whose birthday is omega, but that's extra data.
Hmm.
This is what I was saying before about surreals and hyperreal fields, like not being a lot more than their field structures.
That they're more than the field structures makes sense to me. It's more the relationship between the two.
Yeah, I do want to more understand the relationship.
Like certainly surreals have one very important structure, which is their ordering and birthdays.
Mm-hmm.
Ehrlich has yet another paper on that, where he shows like I think the unfolding of the surreals gives like what is it like? Don't quote me on this. All the linear algebraic groups or something. Order by complexity.
So is he trying to generalize the famous theorem that every set size word field embeds into the surreal field?
Yeah, I think he's also showing that if you like unfold the surreals by their ordering, that it gives you all these familiar sets as well in like some nice way that encodes like other properties of them, like some inherent measure of their complexity.
So with the hyperreal field also, you inherently have, for example, the exponential structure,
Because that's also provided by the ultra power construction.
Have you seen like all the difficulties with trying to make sense of exponentiation in the surreal field?
I've just heard that people have had great trouble defining this and then things beyond that, of course.
But for
The actual-
hyperreals, it's automatic.
Yeah, the actual like what makes it hard or not definable or whatever, no idea.
Well, it's because the structure. So again, the hyperreal structure is precisely about magically lifting properties of the real line to these ultra products, while with the surreals, they are manually built, so you don't automatically just have everything. The plus and times were hard-fought definitions by Conway back in the day.
I remember seeing the times one especially.
Yeah.
That took some powerful schizo thinking to find.
But I guess if there is now a proper class hyperreal definition of the surreals, that would automatically then resolve that issue. If I'm understanding what he proved correctly.
By Leibniz? I don't think this is by Leibniz.
This is a bit older. Wait, what? Oh, I see how Google got confused there.
Yeah.
This is an important thing. Every hyperreal number system is a limit ultra power, right? So that's sort of like the generalized fact that the way hyperreal fields are built isn't ad hoc. That is a characterization of those systems. Right, so I think this is how he resolved the question of how you provide all the structures onto the surreal line. Sort of unifying those two approaches. And there's where structuration comes in. Like that's really the key thing that makes the ultra power construction magical is saturation. This is the thing I want to see. So in MVG, there's up to unique tough isomerism, a unique structure, and for which R is a maximum class. This is necessarily going to be the surreal numbers. Right. Okay.
Is NO the whole surreals or just part of them though?
No, the whole. It's like it's intentionally supposed to be a joke on ON being the orbitals.
Oh, Conway.
Good old Conway.
That was the death from COVID that bothered me the most, actually.
Yeah.
Also,
We lost a real one.
in the YouTube comments, his son like replies. His son was like just starting college.
Really? His son, not his grandson, Gareth? I've met his grandson. I went to math camp with him.
Of course you did.
Conway loved loved math camp. Like he gave us all these wild lectures.
I wish I'd gone into math earlier. Maybe it is his grandson then. How old are his kids then?
I don't know. Garrett's younger than me by a few years.
Okay.
At least. I was pretty sure he was his grandson. John Horn Conway, Gareth Conway.
Son, Gareth.
No, he's also. Oh, this is why I'm. Wait, from his second marriage? Oh wait, so is Gareth from his third marriage? That would definitely explain there being a bit of an age gap.
He married Diane in 2001, had a son with her. Okay.
In 2000. Oh, yeah, that checks out. That has to be Gareth.
This is also giving his age. He was 64 when it happened. This is a very handy wiki extension, by the way. Giving the ages of people.
Yeah, I guess. I guess I was like, maybe he literally said that to me, and I just interpreted it as, oh, my grandson. No, he was literal.
Oh, you're welcome.
I have learned something.
I'm looking for this Levi Sabita calculator.
Let's see here.
So how close are my two? Oh. 2032 serious. There's no welcome here. Fantastic.
Oh, you're going to
The bar.
wait, to the borough?
No, I'm going to Space's birthday party.
When, like nowish?
Let's see here. My foot's here, right? No, I'm not.
Well, you can be. Oh, I guess it is like nowish.
Not that I have to be there right when it starts, but
But you could be totally. This is so close.
Yeah, I was like, yeah, I'm fine if I have to take like a 30-minute drive there. Oh no, it's right there.
It's barely a 30-second jog. Like I know exactly how far it is to there.
also, yeah, this was the thing we were talking about with the Archimedean structure of the real world.
Hypotenuse S can never be set as relative to two arbitrary points. Real plus
So like the context was, I have this theorem showing that the Nash embedding theorem can be done in like an incredibly rudimentary set theory, and this matters to me because like I don't know a priority that our rule exists inside the Platonic V of sets, but instead I just put an ad hoc set theoretic structure around us, and that's enough to assign us real coordinates in an isometric fashion.
Oh yeah, you had mentioned this at the Lighthaven, the whole Nash embedding thing.
Yes, because once we do know that we have real coordinates, then we are a bona fide mathematical structure. Until then, we can only really think ad hocly about where we exist mathematically. That is why I want like a very local way of.
Which one are you? Are you
I'm Kanata, yeah.
Do you
Don't put my name on this computer.
Oh, yeah. Do you know any non-commutative geometry?
No.
I just want to know, like, how do you compute anything non-commutative geometry? Just like a basic example of something.
It always looked like dark magic to me.
Because I've learned about it and Connes through, well, non-standard analysis, because he was once very enamored of it and then went away from it.
I mean, hey, I'm sure there's at least one channel in here where you can reasonably ask that question.
Okay, yeah, maybe.
Maybe advanced algebra or algebra.
I don't like Fallen's book. His measure theory book. Maybe it's I don't like measure theory.
I love measure theory and I love.
Have you met him? Is he alive?
No, I mean I have the book. I never. Now, measure theory matters a lot to me because, well, obviously matters to me. I'm studying all these like
Alive.
research paradoxes, all these randomness paradoxes, so I have to really have a sense of the theory. And I'm the only person who really has a good understanding how to do measure theory without the axiom of choice.
Wait, what?
I said I'm the only person who knows how to do measure theory without the axiom of choice.
Have you not written this out for us?
I will write it up. It's
The
not
people need to
exactly
know.
easy to write up a principled monograph on this, but I will.
One day the computer can dig it out of your brain. Well, maybe at that point it'll be capable of just doing it. Where's the guy's if?
Yeah, I gotta publish my math now before computers can do it all for us.
Ah, here it is, finally.
Need to get tenure ASAP.
Wow, 15 years ago.
What's this?
This is an implementation of the Levi-Civita field.
How is this physically doable?
Because it's not actually implementing the entire field. Because if you, certain expressions, I think if you construct them, especially if you do the division or reciprocal, will just go to hell.
Mm-hmm.
I think its solution for this is to just like give it truncation. Welcome to programming. So it would do something like 1 over 1 minus x as like...
Is it a countable structure?
I doubt it very heavily. There's no way. The real numbers are embedded in this as... Okay, definitely not.
Then again, oh, but okay, only countably many of its elements could possibly have a computer-writable description. Did you see that thread on Math Thoroughflow about the computable surreals?
No.
You should look at that. It's interesting.
All right.
This is like from a week ago.
I'll look at it after then.
So I'll probably head out soon. But yeah,
Alright.
I'll go start